Alrighty, so we're going to continue to talk about mechanical dimensioning here. So we are looking in our textbook here, and so um, there are some mechanical drafting conventions here that are a little different from the ones that we looked at here in regards to vertical dimensions. So in this example that you see here, the vertical dimensions have kept their text oriented horizontally. That's maybe a little bit less common, but that is something that you will see from time to time here. So if I just pull this in a little closer so you folks can have a better look at it, you can see that those dimensions are horizontally oriented. The text is the text of the dimensions, while they're still dimensioning a vertical feature. Now, as we look at maybe the more common method of dimensioning, what they're calling it here is the aligned method, where the dimensions are typically aligned with whatever feature is being dimensioned. So if we were to place a dimension to dimension the length of this face here, we would have witness lines that emanate perpendicularly from that face, and then run our dimension line parallel to that face, put in our arrows, and then put in our text in line with the dimension line. Okay, so moving on to the next page here. So this is what they call unidirectional dimensioning, where the numbers stay um, they stay horizontal. So it's the same direction everywhere. I would say that that is less common. So the different kinds of lines that we have here, so witness lines or extension lines. So this is another term for the witness line. And then the dimension line, which is always parallel to the face in question. So as we look at some of the objects in here that would be and how we would dimension things in uh, our three view drawings, where we have a top view, a front view, and a side view. What we'll do as in way of conventions is you want to keep the dimensions in between the objects as much as possible. And you want to make sure that someone is able to find the overall dimension of an object at least once. Now here, they're providing the bottom length dimension only in this one location. Now, someone could by all means add that extra dimension down here and place that information at the bottom. Now, back when hand drafting was more common, they would tend not to repeat a dimension. And the reason for that was to prevent errors by way of duplication. So sometimes you might, make an edit to this dimension up here, but it wouldn't, the text down here wouldn't change, or you might forget to change that text even if you'd erased these two lines and changed their location. So before computers were doing a lot of this stuff in hand drafting, you'd try to draw those overall dimensions just once, so that way you wouldn't be forced with or wouldn't be faced with the possibility of having a mistake in your dimension value because you had more than one copy of that dimension in the drawing. So again, we're going to try and keep our dimensions away from the white space around the page as much as possible. This is if we're using top, front, and side views. Um, Here, when we're looking at a situation where we're just having a front and a top view, you may need to have, of course, a dimension for some of the geometry in or for the object against the white space around the perimeter of the page. There's just not much that you can do about that. In addition, you can see here what they're doing. They're separating the dimensions apart, and they're also not providing what we would call dimensional continuity. So typically, when we're dimensioning objects now, especially a building, if you imagine that this is a floor plan of a building, we would do a couple things. Number one, we would have a dimension here, and then we would have the overall dimension right next to it for confirmation, right? So we would have those two extra dimensions drawn in there. For mechanical drafting, that's not going to be necessary. And for what we're doing right now, we'll just stick to providing that one overall dimension somewhere. And then you do not need to provide remainder dimensions. All we need are the dimensions required to construct the object. So obviously someone who's working at a machine shop, if they've got this overall dimension, and then they've got this dimension for the toe of this object, that's considered good enough. Okay, so looking at the bottom of the page here, they're saying when it's very clear what the geometry is doing, put dimensions on it. So what they're saying is, look at these two dimensions here. We can see how this the face of the object here articulates. So if you were to draw these dimensions over here in this view, in the top view looking down, it's hard to understand by looking at the top view what this object is doing. So putting dimensions on there, it's somewhat helpful, but having them here is actually more helpful than having them on the other view. So what they're saying is put your dimensions where they describe things the most. So same principle over here. Just make sure that your dimensions match up with the object properly. Good context for both. So here you've got the overall length and overall depth of the object in the top view, and that's being provided in a single view. Over here, you're still getting that same information, but it's not being presented in as organized a manner as possible. Okay, so what they're saying down here, we only need to dimension an object once and always two object lines. So if possible, we don't want to dimension to a hidden line. So in this object here, it's got a slot in the top and it's got a hole in the foot of this thing. So you can see where the hidden lines are being provided. We don't dimension to those hidden lines. So here they're able to dimension to object lines in every case. So here they're dimensioning the hole, and we don't have to dimension to object lines. Now, again, this is more of a manual calculation error avoidance technique. So here they're saying omit one detail dimension in a chain. So here we've got our overall dimension and they're saying to omit this. And again, this just has to do with calculation errors that sometimes happen when people were calculating the numbers that they would put in each one of these dimensions. So not too super critical for us, but that's kind of what we're, it's part of the topic that we're discussing at present. Okay, so here what they're talking about is continuous dimensions. So here you can see that if you're dimensioning from one to the next face, and they're all collinear in terms of where those dimensions could be, then place the dimension line so that all portions of it are collinear as well. So don't stagger your dimensions. So here you can see you've got a consistent spacing between the object line and the dimension line in these three cases. But it makes for a harder read of the dimensions. So here we would make our extension lines, our witness lines longer so that all of our dimension lines can be collinear. It makes them easier to read. Okay, so here they're saying dimension solid object, don't dimension a hole. So in this case, we don't want to dimension where something's being cut out. You want to dimension where there is still solid material. Now, at this point in time, until we start getting into sectioning, you'll notice that there is no shading anywhere on these objects. So it makes it a little bit more difficult to ascertain, where there are solids and where there are voids. So if we were looking at this example earlier, if you're looking at this top view, you could surmise that this hole is not a hole. It could also be something that protrudes upwards. It's not until you look at the front view that you see the dashed lines that you recognize that this is a hole. So there is a little bit of ambiguity in mechanical drawings if you're looking at one single mechanical drawing. It's not until you see all the drawings in context that you begin to realize, that you've got holes in certain places. So our dimensioning convention here is don't dimension the hole, dimension the solid object. And with the extension lines or the witness lines, you want to make sure that there's a gap between the witness line and the object that you're dimensioning. You don't want it right up to the edge of the object, so we don't want to see this. So it's right up to the object. We want a gap. That helps people identify that this is, in fact, a dimension. It's dimension geometry and not part of the geometry of the object. If you are dimensioning something, that witness line is continuous. So once you've put in a 2 mm gap at the object, just run that thing right through, right up to the dimension line. So no break. And you don't want to have this break so long that you can't clearly see what the dimension is connected to. So here we want to run those things right back in so that they're close up against. Where witness lines or extension lines intersect, they will cross. There will be no gaps. Just run them right past each other. And then, of course, it's hard to see even from this textbook looking at it in person. But remember that our witness lines and dimension lines are thin. The dimension line does not extend past the witness line in mechanical drafting. It does in architectural. That's an option. But with mechanical drafting, the dimension line stops at the witness line. The witness line or the extension line can extend past the dimension line some amount, not a huge amount. That's probably too much for what I've drawn. So this would be considered acceptable. But we want to make sure that there's a clear difference in line weight between our dimension geometry and our object geometry. So hopefully that's visible enough here as I'm drawing it. So again, same idea. We're just dimensioning the same feature once. That's partly just to prevent errors from happening. Now, as we get into dimensioning, because of the amount of space that you've got on a sheet, you want to make sure that the amount of white space that you're providing between the dimension line and the object um, is reasonable for the amount of space that you have available. If we look at these drawings down at the bottom here, you can see that we've got a decent amount of white space between the object and the dimension line, and then the adjacent line of the next view above or to the side. So that's kind of a bit of a feel thing, and that's something that you'll just sort of learn about as we go. Let's just see. I'm just trying to see if there's much more that I need to discuss about this. I'm not going to go through the rest of the rules on this. I'll just get them up and have them here on the stream for a second. So if you folks want to come back later, those of you who do not have the textbook, you'll be able to refer to these rules just for your own reference. So you'll just be able to pause the video and look at this stuff. So typically speaking, we're dealing with metric with everything here. In some machine shops, they will deal with inches, and they may do it in decimal inches. Not as common to see, eighths and sixteenths of an inch in machine shops. They'll typically go decimal with their work. Okay, I'm going to stop the stream here and we're going to move on to the exercise that we were talking about that I handed out